Okay, so this is the second part of solving second order differential equation using shooting method. In the last lecture, we saw how we can solve example 2.6.2 of the textbook using forward Euler. Now this time we're going to look at it how we can solve it using backward Euler. So in backward Euler, you have to discretize this using backward Euler. And to do that, I'm going to rewrite this set using backward Euler. So in backward Euler, as you remember, the left side of the equations are almost the same. We don't change anything. So I'm going to have fn plus 1. And then fn and tn are also the same as before. The only thing is, when you evaluate the right side, everything should be at n plus 1. So this tn becomes now tn plus 1. And then this fn is also become, well, this one becomes fn plus 1. Okay, so now I'm gonna have two equations for f and n, for f and t, and we have to group those n plus 1 variables on one side and all other ones on the other. So from the first equation, you see that you have two equations, well, you have two equations with two unknowns, fn plus 1, tn plus 1. Okay, so you bring all of the unknown to one side, so you get an equation for f and t. In the first one, you also get an equation for f and t, both are n plus 1 on the left side, right? So let's do that, and if you do this, then for the first equation we get fn, so this, yeah, so we get minus, now this term, right, goes to the left side, so I'm going to cut that and put it in the left side, and the right side we don't have that anymore, and we're going to have on just minus ta, and then minus actually gets up here. And then for the second equation, I am going to have this term. Let's see if we can highlight it. No, I cannot have to rewrite it. Because it's going to be minus dx times f of n plus 1. Okay, and this term goes away because I brought it to the left side. Okay, so see that I have two equations, two unknowns, fn plus 1, tn plus 1 in the first equation, and then tn plus 1, fn plus 1 in the second equation. So two equations, two unknown. You can solve for fn plus 1 and tn plus 1 in terms of ta, problem constants, fn, and tn. By the way, this should be capital F, like that. And same thing here, should be capital F. Okay, so let's say we solve this, and by, well, solving this is not difficult. We can go ahead and solve two problems, or two equations, two unknowns. And if you do that, then you see the equations as I have on the spreadsheet right here, right there. Okay, so we're going to do the same thing, and we're going to split our x from 0 to 1. Initial f, we don't know, make a guess, make it red here for now, because I just want to emphasize that this is what we don't know yet, this is what we guessed. And temperature at point 0, I know that, that's 100, and put it here. Now, what is fn plus 1? Well, fn and tn plus 1 are calculated, again, using two equations, two unknowns here. So you can do that. I can also go ahead and do that for you. If you want to do this, then what we can do is we multiply the first equation by dx, and then add it to the second equation. And if you do that, then dx fn plus 1 cancel out with this. So at the end of the day, what we get is the following. So if I add the first equation, if I multiply the first equation with dx, and then add it to the second equation, what I get is tn plus 1 from the second equation, right? These two cancel out. And then from the first one, we get minus times, okay, 1 from this first, from the second equation, I get 1 here. From the second equation, I get minus 4 times h divided by d divided by k, now times dx, just multiplied by. Okay, so I added the first, or the left side of the two equations after I multiplied the first one by dx. The right side, I have fn times dx minus dx squared times 4 times h divided by d divided by k times ta. That's the first equation, right side of the first, and then plus the right hand side of the second, plus tn. So here's my tn plus 1. And after I solve tn plus 1, I can put in here and then solve for fn plus 1. Okay, fn plus 1 is tn plus 1 minus tn divided by dx. And that gives me fn plus 1. So first off, I go ahead and do tn plus 1. Okay, tn plus 1 is going to be, let's go to the spreadsheet. Here is the spreadsheet, right here. Okay, so I'm going to do tn plus 1. Tn plus 1 is going to be, let's look at the equation one more time, or maybe move this to this side and move the spreadsheet to that side so we can see both. So here's my tn plus 1 and here's my tn plus 1. Let's see if they match. Okay, so tn plus 1 is going to be this thing raised to the negative 1 power, because we're going to divide through both sides by this. This is just problem constants. So that's why I have 1 minus 4h over d over k. That's b6, right? I'm sorry, that's dx. So 1 minus dx. Let me see here. Okay, so there's a typo here actually. Then let's double check. When I multiply the first equation by dx, I forgot, actually before that, when I moved my tn plus 1 to the left side, I forgot a dx here. So there is dx here that is missing right here. So I'm going to multiply this by dx times that. Okay, now this equation is correct. And then because of that, I should get dx squared for this term. So this is going to be dx squared. Because when I multiply both sides by dx, there's already one dx here. So then this becomes dx squared. Okay, now I think this is right. You can go ahead and solve this. So let's look at this equation one more time. This is tn plus 1 is equal to 1 minus 4. So here's 1 minus, this is 4h over dk, right? And then times dx squared. So here's dx squared. And all of them raised to the negative 1 power, because we're going to divide by this prefactor. And then on the right side, I have fn times dx. So here is dx, and then times fn. And then I have minus dx squared. So here's minus 4h dk here. This is dx squared, right? 4h dk, dx squared, and then ta. So here's ta, all right? And then plus tn. So here's tn, which is previous cell. That's this purple cell. Okay, so this is tn plus 1. Is a little bit involved, but I think we managed it. Okay, and what is fn plus 1? Well, fn plus 1 is easy. As long as we have tn plus 1, we can solve for fn plus 1. So fn plus 1 is going to be, we can solve it from here. That would be tn plus dx, I'm sorry, tn plus 1 minus tn divided by del x. So I plugged in just Tn plus 1. We know it from here, right? This is Tn plus 1. We just solve it here. And then you subtract Tn from it, divide by dx. And that's what I have here. So from here, let's see. Let me double check again. This is Fn plus 1. We can actually, we can do it this way. So this is a bit longer than what I expected. I'm going to rewrite it this way. So this is going to be Tn plus 1 minus Tn, right? And then divide by dx, which is this one. I'm going to freeze the indices. Okay. So this is going to be Fn plus 1. And the rest is you just highlight these two and drag down, and that's what you get. Okay? Alright, so, and you see that when I solve the problem, I draw backward Euler solution, t against x, this is the red line, and doesn't match the forward Euler at all. Forward Euler is completely different, and the error actually comes from the other end. The other end, the temperature should be 0. Right now it's 2000, and the reason is my guess is bad. So I have to change this -1, but how should I change that? Well, I have to change it such that I get 0 here. So I'm going to make a goal-seek using goal-seek solver. So here's goal-seek. Okay, I'm going to do this cell, set that to 0 by changing my guess, which is this first cell on F. And you see that now red line goes down. Now it matches the two boundary conditions. I'm going to make it a bit smaller. So you see right here, temperature is 100 on this side, 0 on the other side. Red is backward Euler, blue is forward Euler. We did it before, and there's a little bit error between the two. Yeah, we know because they're two different methods. But at least it satisfied the two boundary conditions correctly. Okay, so this was shooting method using backward Euler. Shooting method, again to recap, is used when we have two boundary conditions on two different points along the domain or interval. Okay. In chapter 5, we always had boundary conditions or initial conditions on one side. We didn't have on both sides. If the boundary conditions are given on both sides, then we have to guess. We have to guess the boundary condition of one of the variable on one side, solve the problem, and then make a goal-seek by changing our guess value to make the other boundary conditions on the other side correct. In order to make it correct, you have to change the initial guess of one of the boundary conditions on one end. And we did that using heat conduction in a rod, using forward Euler and backward Euler. Right, stay tuned for the next video on solving differential equations with split boundary conditions in chapter 6. Thanks for watching.